Okay, so this right here is a Baniter style 8-bit computer clock. So it's the first module of the entire 8-bit CPU, which I'm going to build. I'm trying to build. Hopefully, I'll do it complete. So I was able to make the clock work completely, and this thing is working. So before going to the pad, I decided, or I thought, just why not record this a complete video where I explain the working of the entire 8-bit clock, how it is working and how it is being used in order to sync between other services in a computer machine. So clock is generally used, you know, we even use clocks to sync ourselves, to meet someone, or to catch a train, to catch a flight. So right here, if you look that there, let me put this a bit more in light. So here are three 555 ICs which I used, and three output signals also being highlighted with the yellow LEDs. Now here's the first module, which is in the astable mode. As you can see that it's not being able to stable by itself. So if you kind of tweak the rheostat value, if you minimize the resistance here, the input resistance here, so it's a 1 mega ohm resistance with variable resistance. And right now, as you can see, I have supplied two 1k resistors also, so 1k resistor here also, in case it doesn't becomes completely zero. But as you send this, so it is actually flashing, but it's way fast, so we are not able to see it. So that's the thing. So as soon as we started to rise the resistance, the glow started to change. The LED would change its flash. So I think we got the idea here. So resistance means it's taking more time to send this electricity here, signal. And now here, this capacitor, as you can see, this is a 3.3 microfarad capacitor which I used. So if you can see, yeah, you can see now. So it's a 3.3 microfarad. I wasn't able to get the 1 microfarad. I don't know, the shopkeeper didn't give it to me, he just gave it. But here, what this thing is serving here as like a charging station, or you can think of it like a base, a beaker, where you just wanted to make sure you have a steady flow, or you wanted to divide or supply a particular amount of voltage or current or flow to the network, to the chain here. So here it is 3.3, and basically what it is doing here, we are supplying a 5-volt supply, and this has around three resistance inside, a 5k ohm each, so hence the name 555, uh, which makes sense intuitively, and even the band itself has explained this. So here, what it is doing is it's just kind of charging this up, and it's then releasing it, and it's being connected to the last IC, so SR to the set part. So it's getting set after every 1.33, 1.6, I think 1.67 something voltage here, and this thing is filling up to 3.3 microfarad. So you can't just do have to do the maths. uh, just do the maths. It's not that really tough, but that's what it is doing. It's just filling up and it's just releasing that, and we are having that set reset kind of thing going on here. So it's not being in the stable mode. So that's what is actually going on. Now here is a resistance to just to make sure that we don't burn our LEDs. I did actually burn one. I didn't. I was just like testing why we're using this resistor here to make sure the LEDs don't burn. The one property that LEDs have is they don't have any sort of limit on the usage of current. As soon as you start to supply a current, they just start to bring more and more, and they just burn up because they just want to that's what their property is. So you have to add in current limiting resistor in order to make sure that you are supplying a constant amount of voltage current, so they just don't get burned. So this is a property of LEDs, kind of they lack something, that they're not able to hold what exactly they are designed for. So you need to make sure that they are supplied with the proper amount of voltage or the current here. Here this capacitor is, I think I have used a zero point zero 0.01 microfarad. What it is doing is just kind of just stabilizing the entire network supply of the current. So it's kind of like a small charging station. So if there are any fluctuations, this kind of providing like a tank, a water tank. Same goes with this electrolytic capacitor here. And after this thing is done, we now move towards the monostable mode, and in this monostable we only have one mode. I'll show you that white, that blue LED is also glowing with that, but this is just simply just connected to this button to supply this current here to this LED. And this 555 IC is being used as the SR latch is being used here as to avoid the multiple mechanical faults, since these buttons could have the faults and they can actually fluctuate between the states. You can have like 3 clicks at the one time, so if you not being careful, if you wanted to make sure that you only have 1 and 0 instead of 1 1 0 or anything like that, so that's what it is doing here. Then here is an interesting piece of circuit. This is basically a switch. It transitions between two states, so we are using this to supply a ground, a 0 voltage to this NOT gate, and here to the AND gate also, to make sure to change between the states, to change the states between these two clocks. So if I switch this, it now switch to the your monostable mode, and here this output actually makes that this is now high because it's now being changed, and this is being high here. So you can make sure that you're doing exactly what you wanted to do with the circuit. Now here is a NOT gate, AND gate, and an OR gate. What NOT gate is doing is just making a distinction between these two to help us to decide which gate or which clock are we using. And here AND gate is being used to make sure that we are supplying the exact thing here, and the OR gate is just kind of mixing up these two along with the halt line. So we are also having a halt line here, so in case you want to keep running your clock and you don't want to supply the current to the rest of the network, you can simply just halt the circuit by making it high. So this thing is now high, and we are just having our clock as it should be. So it's just kind of disconnecting with this AND gate, and we are providing this to the NOT. So this NOT gate is feeding this here to make sure that we have a halt here, and that's what basically this entire thing is, this entire clock circuit. And it's not so fancy, so I thought, okay, so let me just pause. I thought, why not just make an explanation video, because I didn't did in my other channel. I just over there showed my daily progress, what I missed or what I made a mistake, or how was I able to complete it or not. So here is this explanation in order. I just made it so just to make sure that I really understand. So here is the clock working, and as you know, let me just do this. Yeah. So. Yep.